All right, hello everyone. Today we're going to LeetCode 113 path sum 2. Given a root of a binary tree and an integer target sum, return all root to leaf paths where the sum of the nodes. All right, hello everyone. Today we're solving LeetCode 113 path sum 2. Given a root of a binary tree and an integer target sum, return all root to leaf paths where the sum of the nodes values in the path equals target sum. Each path should be returned as a list of node values, not references. A root to leaf path is a path starting at the root and ending at any leaf node. A leaf node is a node with no children. So as you can see, the leaf nodes or any nodes with no children would be 7, 2, 13, 5, and 1. And we have to see, hey, is there a path between the root 5 and any of these leaf nodes that add up to 22? 5 plus 4 is 9, plus 11 is 20, plus 2 is 22. So therefore, we could say that this is a correct path, and we append it onto our res, so we have the path here, all the values. And another winning path will be 5, 8, 4, and 5. That adds up to 22, so we append that on. But there's no other path that adds up to 22. 5 plus 8 plus 13, no. 5, 4, 11, and 7, no. And 5, 8, 4, and 1, also no. So we return only the two paths that add up to 22. Hopefully that makes sense and you guys understand. Let's get into how we'd solve a problem like this. So what I like to do, when we read the problem, it says we need a root to leaf path. So that tells me that we're going to be using DFS, depth first search, because we need to go from the root all the way down and then recurse back up and try another path. So how are we going to do that? Well, we're going to have some way to keep track of all the nodes we saw in the path. So our DFS is going to have the node that we're currently at and an array, which is going to be a representative of the current path. So let's just say it looks like an array, and it'll have all the values of nodes we've traveled to along the path. And we're going to do DFS on the left and right subtree of every node starting at 5. All right. So I'm going to use green to show you guys where we're at inside of the path. So if we start at 5, we always go DFS node.left. All right. So currently our path has 5 and 4. We go into the dot left and we have 5, 4. We go dot left again. Now we add the 11. Go dot left one more time. And we say, hey, we are at a leaf node. A leaf node means that this is the base case because this is the last node in our traversal because we need to return a root to leaf path. So if we're at a leaf node, we know this is the last node. So all we have to do is add it on there and say, hey, does the sum of our path equal the target sum? And we add all the numbers up together and see, does it equal the target sum, which is 22. And we do that and we say, well, 5 plus 4 is 9. Plus 11 is 20, plus 7 is 27. 27 is not equal to 22. Therefore, we do not append anything to res and we recurse back up. So now we are currently at the 11 because we have to go back up, right? Now we go to the left subtree of 11. And since we went up, this call no longer had the 7 because we're back here where the 11 is. So we never added the 7 because we backtracked back up. So we have to erase that. And now we add the 2. Same deal here. We say, hey, we're at a leaf node, so we know this is the end of the path. Does the path sum equal the target sum of 22? Well, 5 plus 4 is 9, plus 11 is 20, plus 2 is 22. 22 equals 22, so we'll say, hey, this is the correct path. Let's actually save it to our res. So we save it there, all right. And you might think, what do we do next? Well, since we've explored every single node on the left subtree of 5, now we have to explore the right subtree. So we're going to go DFS node.right. And since we went .right, that means that all of these nodes are no longer going to be in the path. It's almost like we started from 5 because this is the current path we're on. We're going from the 5 down, right? So dot left, we're dot right, right? We're at the 8. And now we go DFS node.left. We add the 13. And this is a leaf node, so this is our base case. We add up the sums of the paths. So 8 plus 13 is 21, 21 plus 5 is 26. 26 is not equal to 22. Therefore, this is not a valid path. So we need to recurse back up, and now we're at the 8, right? And we need to go to the right. So that means we delete the 13 because we've on a different path now. We go to the 4. We add that in. We go DFS node.left. Add the 5. And we say, hey, we're at a leaf node, so we know this is the end of some type of path, a root to leaf path, but is this path valid? So we add up all of the numbers. 5 plus 5 is 10, plus 8 is 18, plus 4 is 22. We say, hey, 22 is equal to our target path sum, so we append that on. So we get there we go. But we're not done yet. We still have to check the last node, which is right here. So we recurse right back up. And remember, we're going to erase the 5 because we no longer added 5. We're back at the 4. We go down the tree to the DFS node.right. We add the 1 and we say, well, this is a path from the root to the leaf. Is it valid? 5 plus 8 is 13. Plus 1 is 14, plus 4 is 18. 18 is not equal to 22, so this is not a valid path. And we've explored all nodes, so DFS will end. And now, all we have to do is return res. Whatever is inside of our res is all the valid paths that add up to the target sum. All right? So let's go into actually how to solve a problem like this. So the first thing I like to do is say, hey, what about a base case? What if they give us a binary tree with no root? So there's no nodes inside this binary tree. So if not root, return just an empty list because there is no paths, right? Now we want to actually take care of our recursive function. So we need a res to store all the valid paths. And next we want to create a function for depth first search. So define function DFS, and it's going to take in 2 parameters. One, the current node that we are at, and second, the path. So it's going to have all the values of paths all to that node, right? First, we need to take care of the base case so our recursive function doesn't run forever. And our base case is, well, if we get to a leaf node, then we need to check the sum of the path, and if it is valid, we append it to res, and if not, we just return. All right, so if not node.left and not node.right, so that means if we are at a leaf node, which means we're at a path that is from the root to the leaf, and the sum of path is equal to the target sum, that means that we have found a valid path. So this first part makes sure that we found a path, and the second makes sure that we have a valid path. Now we have to say, well, res.append path and return. All right. Now we have to explore the left and right subtrees. So first we have to say, hey, well, does this node even have a left and right node? So if node.left, then that means we can do a DFS call on the node.left. So node.left will be our new node that we're going to go explore. And for the path, what we're going to do is say path plus, and we're going to be using an array, and node.val, well, .left.val. You might say, wait, why are we doing this weird like addition thing? If the path is going to be an array of values and we need to append on a new one, let's say the path had 5 in it from the beginning, and we need to add the 4 because we just added it. So like, let's say we go 5 to 4. We can't just add 4 because that would be adding an integer to an array, which does not work. We need to put it inside an array, and that would output 5, 4. There we go. And same thing if you added another node here. So let's say plus 3, it would be 5, 4, and then 3. So that's why you have to make sure you wrap it in an array so they all are in a valid path, and we can append that because it's the same format as the output, right? Next, we have to copy this down because anything we do to the left tree, we have to do to the right tree. So instead of if node.left, because we need to now check if the node.right, and append that val to the path so we know it's there. Perfect. So now all we need to do is actually call the function. So DFS and we're going to use the root as the first value. And as for our path, we can pause and think about what we do, but we're going to have an array, and we need the root dot val, because if you see, all paths have to include the root, and that's going to be our first node, so we make sure to add it in there first. And then as the iterations go down, it'll add the corresponding nodes to the path. And now all we have to do now is return res, because this should have all the valid paths. And let's see if it works. All right, and we solved the question, and it's pretty efficient. I hope you enjoyed the video, and if you have any questions, peace. Make sure to drop a like if you found this helpful.